Hello friends, in this video I am going to deal with the concept of parabola. See, I am going to discuss main 10 points related to the parabola which are very useful for attempting the mains examination. See, these 10 points I am going to deal in this video. Those 10 points are the definition of the terms of the parabola, standard form of the parabola, parabola whose axes are along the coordinate axis, and definition form of the parabola, general form, axis and the tangent at the vertex form, tangents and normals of the parabola, and S1, S11, S12 related to the parabola, point of intersection of tangent and normal for the parabola, parametric point related ideas for the parabola. These 10 conceptual ideas are very helpful in attempting different problems of previous mains questions as well as coming mains examination also. Okay, so one by one I am going to deal these items, right? Now first of all, let us see the definition and the terms of the parabola. See, basically what is parabola? Parabola is the locus of points which are at equidistant from a fixed point and to a fixed line. Basically, we need a fixed point and we need a fixed line. If you collect the points which are at equal distance for these two. See, this is the point which is equidistant from the fixed point and the fixed line. Like that, if you have another point here, clearly this is equidistant from the point as well as from the line. Like that, if you collect all the points will form a curve and the curve is the parabola. So this is the parabola. As per the definition, every point on the parabola is equidistant from this fixed point as well as from this fixed line. Okay, this fixed point is usually termed as focus as well as this fixed line is termed as directrix of the parabola. That is focus as well as this fixed line is the directrix. Right? And as per the definition, this point V is also equidistant from S and F. See, this is focus and this is the directrix. This line is perpendicular to the directrix and passing to the focus is usually termed as axis of the parabola. And this is the axis and this is the curve. The point of intersection of the curve with the axis is the axis and this is the curve. The point of intersection of the axis with the curve is termed as vertex of the parabola. Right? And if you draw a tangent at this vertex for the parabola, that is mentioned as tangent at the vertex, tangent at the vertex for the parabola. And the point of intersection of the directrix with the axis is termed as F, which is the foot of directrix, which is usually termed as the foot of the directrix. And for any point P on the parabola, these two distances are same, and this distance is usually termed as focal distance. What we call it as focal distance of the parabola. So these are the basic terms like focus, vertex, foot of the directrix, directrix, tangent the vertex as well as axis, and the focal distances is the terms. And in generally, some more terms are also related to the parabola. So for example, if you have a parabola and if you take any 2 points on the parabola, by joining these two, we will get a chord. This line segment joining any 2 points of the parabola is called as chord of the parabola. What it is? Chord. And see, if you have a line which this is the axis, if you say, if you have a line chord which is exactly perpendicular to the axis, this is the chord as well as perpendicular to the axis is usually called as double ordinate. This is called as double ordinate. Chord and then double ordinate. And one more thing is, somewhere if you have focus here, if you have a chord which is passing through this focus, this is called focal chord of the parabola. This is also basically a chord, but it passes through the focus. So here we have 3 terms: chord, focal chord and double ordinate. Everything is a chord. If it passes through focus, it is called focal chord. If it is perpendicular to the axis, it is called double ordinate. If it satisfies these two, then in a sense a chord which is passing through the focus and perpendicular to the axis is called as latus rectum. The important idea is latus rectum. Latus rectum is a chord which passes through the focus and perpendicular to the axis. Okay, so this chord, double ordinate focal chord, latus rectum, along with these terms, is the first conceptual idea of parabola. Definition and the terms. Okay, just have a look here, and then I will come with the second conceptual idea. Right. In this first conceptual idea, we discussed about the definition and the terms of the parabola. And if you observe the diagram what I have here, see in this directrix and this tangent at the vertex as well as the latus rectum, these three are parallel and these three lines are perpendicular to the axis. And this is the one idea, one observation which we need to memorize. And one more thing is, see this vertex is the point of intersection of the curve with the tangent to the vertex, as well as this focus is the this foot of the directrix, right? This is the point of intersection of the directrix with the axis. So these two ideas we need to memorize, right? And coming to the second conceptual idea is the standard form of the parabola. For the standard form, the axis should be x-axis as well as vertex should be origin. If the axis is x-axis and the vertex is origin, then that parabola is said to be in standard form. See, if this axis is x-axis, that means whose equation is y is equals to 0 and this vertex is 0, 0. At a certain distance, we need to select focus. See, if you say that distance as a, this distance is also minus a. Since this is a, then this point will become, since it is on x-axis, a, 0. And this is minus a and this is perpendicular to the x-axis, whose equation will become like x is equals to minus a. And this is origin perpendicular to the x-axis, its equation will become like x is equals to 0. Right? With these parameters we can calculate everything. Since this is a, see if you calculate the locus of the points on this parabola, that locus we will get it as y square is equals to 4ax. So finally what I am going to tell you is, the standard form of the parabola is y square is equals to 4ax, and for this y square is equals to 4ax, axis is the x-axis and vertex is the origin. Now see, if you consider that standard form of the parabola y square is equals to 4ax, if you leave everything, just concentrate on the different points and the equations related to the standard form. See, this y square is equals to 4ax is standard form. Then for this standard form, what we have to say, focus is a, 0. See, we are familiar with the focus. Usually it is termed as s. Focus is a, 0. Vertex is 0, 0. Vertex is 0, 0 origin, whereas the foot of the directrix is minus a, 0. And then, see, this is a point, any general point on the parabola is 80 square, 280. If you replace x with 80 square and y with 280 here, it satisfies. For any value of t, for any real value of t, this 80 square, 280 is an arbitrary point on this parabola. So we call it as parametric point of the parabola. So 80 square, 280. Then coming to the ends of the latus rectum. See, as we discussed, see if this is the parabola and this is the focus s a, 0 passing through this perpendicular to the axis is the length of latus rectum. See, so since it is passing through a, 0, if you replace x with a here, you will get y value as plus or minus 2a. So 2a here and then minus 2a here. So ends of latus rectum are a, 2a and then a, minus 2a. And the distance between these 2 points, if you calculate, this is 2a and this is 2a, totally 4a. So the length of the latus rectum is 4a. As well as if you try to find the equation of this latus rectum, perpendicular to the x-axis, passing through the a, 0. So the equation also become like x is equals to a. See, coming to the latus rectum, we have different ideas. If the focus is a, 0, ends of the latus rectum are a, 2a, a, minus 2a. Length of the latus rectum is 4a and the equation of the lattice rectum is x is equals to a. So we have equation of the lattice rectum, endpoints of the lattice rectum, length of the lattice rectum, right? So usually for this parabola standard form y square is equals to 4ax, ends of lattice rectum, length of lattice rectum, and then equation of the lattice rectum. As we mentioned, Axis of this standard parabola is x-axis, y is equals to 0. Tangent at the vertex is the y-axis, whose equation is x is equals to 0, and the directrix is x is equals to minus a. As we mentioned, this latus rectum, directrix, as well as tangent at the vertex, these three are parallel and these three are perpendicular to the axis. Okay, so these are the different identifications, different items for the standard form of the parabola y square is equals to 4ax. For example, if you have a parabola like y square is equal to 36x, if you say it as 36x, we will identify that a is equals to 9. So by replacing a with 9 in all these terms, okay, in all these ideas, if you plug in 9 in the place of a, you will get focus, parametric point, and so latus rectum, and if you need focal distance and everything, you will get. Okay, and for example, if your equation is like some y square is equals to minus 4x, simply y square is equals to minus 4x. If it is y square is equals to minus 4x and the value of a is minus 1, you just plug in minus 1 in the place of a. Then again you will get all these terms related to the parabola y square is equals to minus 4x. And we will answer the corresponding question related to that one. Okay, so this is the standard form of the parabola. And if you observe the shape of the graph, see the graph of this standard form y square is equals to 4ax. If that a is positive, then that parabola is a rightward parabola. If a is positive, the parabola is rightward, and if a is negative, the parabola is leftward. Okay, and the remaining values and the locations, everything are same. Just the shape is in these two cases. If a is positive rightward, if a is negative leftward. See, similar to the y square is equals to 4ax, we have one more standard form. Usually we call it as x square is equals to 4ay. X square is equals to 4ay is also mentioned as the standard form. For this, vertex is origin, but the axis is y-axis. See, if a is positive, in this case, if a is positive, the graph is upward parabola. If a is negative, the graph is downward parabola. So for x square is equals to 4ay, how to calculate all these terms? See, if you observe this y square is equals to 4ax as well as x square is equals to 4ay, the major change is that x and y are interchanged. Based on that, everything will get interchanged. See, if you need to identify focus for this x square is equals to 4ay, you just interchange these two, 0, a. Vertex is 0, 0. Whereas foot of the directrix is 0, minus a. Whereas the parametric point is just interchange these two, 2at, 80 square. And then if you need ends of the latus rectum, you just interchange these two, plus or minus 2a and then a. But the length of the latus rectum won't change. For both the cases, lengths won't change. Just the shape is, here the shape is rightward, but here the shape is upward. Lengths won't change, its locations will change. Since the locations are changing, we will get different coordinates for all these points, right? In the same manner, if you need axis, x is equals to 0, tangent at the vertex, y is equals to 0, directrix, y is equals to minus a, lattice rectum, equation of lattice rectum, y is equals to a. So if you memorize all these equations and then the coordinates of the points for y square is equals to 4ax, automatically you will answer for x square is equals to 4ay also. You just try to identify the difference between this y square is equals to 4ax and x square is equals to 4ay. That's enough, right? So this is the second conceptual idea of the parabola. Then coming to the third conceptual idea, you just have a look here and I will come with the third conceptual idea. Third conceptual idea is the parabola whose axes are along the parallel to the coordinate axis. See, for y square is equals to 4ax, the parabola is, the vertex of the parabola is at the origin. If this is the origin, the parabola is at the origin. Okay, this is the coordinate axis and this is the parabola. Whereas coming to the equation of the format y minus k whole square is equals to 4a times of the x minus h. See, if this is the y-axis and this is the x-axis and this is the origin. See, for y square is equals to 4ax, the vertex is at origin, so the parabola is at the origin. But y minus k whole square is equals to 4a times of x minus h, the vertex is at h comma k. Somewhere if you have h comma k point here, then the parabola is The vertex of the parabola is at this point. The axis of the parabola is parallel to the x-axis. The what we call tangent at the vertex is parallel to the y-axis, and this is the parabola. See, the major difference between these two is actually the parabola for y square is equals to 4ax is here, but the parabola of y minus k whole square is 4a times of x minus a h is there. That in the sense, see, if this is the parabola, okay, if this is the parabola, we are moving the parabola rightward by h times, and we are moving the parabola upward by k times. If this is the position of the parabola, rightward h times and upward some k units, we just moved that parabola, translated that parabola. So with this basic idea, since we have all these terms for the y square is equals to 4ax, then for y minus k whole square is equals to 4a times of x minus h. See, no need to memorize different forms, different locations, the points and everything. Just it is enough to memorize all these things. And this is also very simple from the basic definition and the diagram. See, if all these things are clear, then for this y minus k whole square is equals to 4a times of x minus h, you just rise that x coordinate by h units, whereas the y coordinate by k units. You will get again the vertex, focus, ends of lattice rectum, everything. See, for this, if you need to mention the focus, you just rise this x by h units and then y by k units. X coordinate is a, rise it by h units. Y coordinate is 0, rise it by k units. And for the vertex, see, h comma k, rise x coordinate by h units, y coordinate by k units, and the vertex is h comma k. 80 square comma 280, rise the x coordinate h plus 80 square and y coordinate by k, k plus 280. So this is the parametric point on this parabola, right? Whereas coming for the ends of the lattice rectum, the same thing, you just rise x coordinate by h as well as y coordinate by k. So there are two ends of the lattice rectum, h plus a comma k plus 2a, h plus a comma k minus 2a. Whereas coming to the length of the lattice rectum, length won't change actually. You need to identify it, because the position of the parabola is changed. Since the position is changed, locations are changing. Location is nothing but the coordinates of the points. So the coordinates are the coordinates will get different values, but the lengths won't change here, right? See, whereas coming to the axis, here the axis is y is equals to 0, right? This is x-axis. What is the axis? Parallel to the x-axis at a distance of k units, you just rise y by k. So here it is 0, rise it by k, y is equals to k, and this is x is equals to h. You need to rise it, x is equals to h minus a. You need to rise it, x is equals to h plus a, right? If you have for y square is equals to 4ax all these values, using this we will write all these values and the equations for y minus k whole square is equals to 4a times of x minus h by rising x by h and y by k, right? In the same manner, we are able to write all these values, locations, equations for the parabola x minus h whole square is equals to 4a times of x minus 4a times of y minus k, right? For using x square is equals to 4a. The second conceptual idea of the parabola, I mentioned writing all those values for x square is equals to 4ay. Using that, we are able to write all these for x minus h whole square is equals to 4a times of y minus k also. Okay, in all these four, the first two, y square is equals to 4ax and x square is equals to 4ay are the standard forms, and then the next two are the forms of the parabola whose axes are parallel to the coordinate axis. And then if you observe these two, right, if you try to simplify these two, you will get the general quadratic forms. I am going to mention here. What are the general quadratic forms in the sense? For example, if this is y minus k whole square is equals to 4a times of x minus h, if you try to simplify, you will get that x is equals to some ay square plus by plus c. In the same manner, if you try to simplify this x minus h whole square is equals to 4a times of y minus k, you will get this, it is of the form y is equals to ax square plus bx plus c, usual quadratic format. See, since this is usual quadratic format, then for this parabola, if you try to find vertex, vertex is minus b by 2a comma 4ac minus b square by 4a, as well as the length of the lattice rectum is 1 by mod a. This is the one idea useful thing for this form. Y is equals to ax square plus bx plus c represents a parabola whose length of the lattice rectum is 1 by mod a, and then vertex is minus b by 2a comma 4ac minus b square by 4a. Using this we will mention that vertex and then length of lattice rectum for this coordinate also. Length of lattice rectum won't change, the same thing like 1 by mod a, whereas the vertex is changing by x coordinate and y coordinate by interchanging the coordinates of x and y. Okay, so for the third conceptual idea, we need to memorize these two forms of the parabola along with these two forms also, right? Then coming to the fourth conceptual idea of the parabola is nothing but definition form. See, what is the definition? Locus of points which are equidistant from a fixed point and a fixed line is the parabola. So based on that definition form, if you have the fixed point focus as alpha comma beta, and the fixed line directrix is nothing but Lx plus My plus n is equals to 0, then we are going to find out the locus of P such that, see how we need to find out the locus of P such that this is equidistant from focus as well as from the line. So the distance between these two is what? X minus alpha whole square plus y minus beta whole square. That since it is the distance, have a square root. And coming to here, the distance between the point and the line is nothing but modulus of Lx plus My plus n divided by square root of L square plus m square. Distance from the point to the focus as well as from point to the line. See, you just square on both sides. This square root will get cancelled, and this side you have square here, and again this square root also get cancelled. See, if you observe, x minus alpha whole square plus y minus beta whole square is equals to mod Lx plus My plus n whole square by L square plus m square represents parabola. And for that parabola, S is equals to alpha comma beta is the focus, whereas Lx plus My plus n is equals to 0 is the directrix. See, since this is the focus and that is the directrix, we are able to find out the axis also. Using these two, focus and the directrix, from these two, we will get axis. Because axis, equation of axis is perpendicular to the directrix and it passes through the focus. So take a perpendicular slope of this one, and as alpha comma beta is the point, from that we will find axis. After having axis, see, point of intersection of the axis and then directrix will give us the foot of the directrix. After having foot of the directrix and then focus, midpoint of these two will give us vertex also. Like that we will find out different ideas. And then see, if you have the focus and then vertex as well as the foot of the directrix, the distance between this vertex and this focus, so usually in standard form it is A, and the length of the lattice rectum is 4A. So if you have this distance, and by multiplying this distance with 4, you will get the length of the lattice rectum also. And see, this is the focus, and this is the length of the, this is the directrix. This is the directrix. Okay, so directrix will be here, focus will be here. If you find out the distance from the focus to the directrix directly, distance from focus to the directrix. After finding this distance, we just multiply with 2. It will give us the length of the lattice rectum. See, length of the lattice rectum is 4A. Okay, what is the length of the lattice rectum? 4A. It is usually mentioned in different ways. Okay, this 4A can be mentioned as 4 into A and then 2 times of 2A. Is it clear? What is 4 into A? 4 into A is nothing but distance from focus to the vertex, and 2 into 2A. 2A means distance from focus to the directrix. If anybody asks you to find the length of the lattice rectum, if it is not in standard form, then we will use these two ideas. By finding A or 2A, we will multiply with 4 or 2 to get the length of the lattice rectum. And this is the fourth conceptual idea of the parabola, which is nothing but the definition form. Having focus and directrix, we will get the equation of the parabola. Right? Then coming to the fifth conceptual idea. Fifth conceptual idea is the general form of the parabola. If we have a general second degree equation in two variables like ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equals to 0. This general second degree equation in two variables represents different conics in different situations, right? See, if you find out the value of delta usually you mention it as the value of delta is the determinant of ABC with hgf and then hgf. If you find out this determinant, and if it is not equals to 0, as well as h square is equals to ab. right? H is the coefficient of that xy. From there you will get, and then you have AB also. By satisfying these two conditions, this general second degree equation in two variables represents a parabola. So this is also we need to keep in our mind to identify the parabola. So this is the general form of the parabola, right? Then coming to another form, if you have axis as well as the tangent at the vertex. See, the standard form is what usually y square is equals to 4ax. By observing this y and this x, okay, if you have it, this is the coordinate axis, standard form. So this is the axis and this is the tangent at the vertex. So if you have any point in this coordinate system, this distance is usually mod y and this distance is mod x. So based on this mod y and mod x, if you have these perpendicular distances, then the equation of the parabola is nothing but mod y square is equals to 4a times of mod x. With this basic idea, after having axis and the tangent at the vertex, we will find out the equation of the parabola. So the sixth one is axis and the tangent at the vertex form. Usually axis and the tangent at the vertex are perpendicular to one another. If the axis is Lx plus My plus N1 is equals to 0 and the tangent at the vertex is perpendicular to this axis, so we will write like Mx minus Ly plus N2 is equals to 0. If you have this axis and then tangent at the vertex, then the equation of the parabola is nothing but, see, the distance from any arbitrary point to the axis. Okay, so it can be written as Lx plus My plus N divided by root of L square plus M square of whole square, like mod y square, is equals to 4a is nothing but length of the lattice rectum LLR into distance from the point to the tangent at the vertex, which is nothing but Nx minus Ly plus N2 divided by root of M square plus L square. So this is the form of the parabola whose axis is Lx plus My plus N1 and tangent at the vertex is Mx minus Ly plus N2. So usually by giving axis and the tangent at the vertex, they don't ask you to find the equation of the parabola. But if you have a general equation in this format, you need to identify it as a parabola with axis as this one and then tangent the vertex as Mx minus Ly plus N2, right? So this is another form of the parabola. So basically these are different forms of the parabola. Just have a look here and I will come with another conceptual idea of the parabola.